So let's go to the lesson. And I want to start with just a little warm-up question. In the last lesson, we spoke about compound interest and simple interest. Today is going to focus on compound interest. And I want you to choose an option from those three, for those four, as we go to this. What is the value of 8,800 after 3 years at 7.5% compounded monthly? I'll give you the basic formula, but you need to think about, what does this do? When I say compounded monthly, what does that mean? And how does it affect things? Who feels like they have an answer? I'm here. Can you just confirm that everything is okay? Can you hear me okay? Can everyone hear me and see me okay? It just feels a little bit like maybe it's not coming through so clearly. Awesome. Pop your answers in the chat when you feel like you've got them. For me, the compounded monthly, the way that I take this into account is I actually have to chop the interest rate up by 12. But when my interest rate is per month, my time periods need to be per month. And so it can't be 3 anymore. It needs to be 3 times 12, which is 36. So I'm going to do this, my calculator, but you can put your answer in when you feel like you've got it. Over 12 to the power of 36. Now, I think that might have caught a few of you. And I get 11,012.73. So 11,012.73. So one of the things I want to point out at the beginning of this lesson is that even though your nominal rate, we call this the nominal rate or the base rate, is 7.5% per annum. If they say compounded monthly, we chop that interest rate up, we divide it by 12, and we make it a monthly interest rate. And then we also change the N from being years, we change that to months because of the compounded monthly. So give me a thumbs up if that part, the dividing by 12 and the timesing by 12, makes sense in relation to the compounded monthly. It's an important idea. It's one of the main ideas that we want to make sure we absolutely nail down today. All right. Well, then let's go to a next question. And in this next one, it says, how much money should Amy invest at 11% per year if she needs 25,000 in 5 years' time? Now here, the assumption is that they don't say compounded monthly, this would be compounded yearly. And also, if they don't mention anything, you can assume compound interest. So what they're not asking for anymore is they're not asking for A anymore. What are they asking for? That's the compound interest formula. What are they asking for in this question? Yeah, they're asking for the initial value P. So see if you can work out what that is. What do we think? I suppose we can start by putting the values in that we know. So we know we need to end up with 25,000. We know the interest rate must be 11, and it's dividing by 1 wouldn't do anything, and this needs to be 5. And we need to figure out what P is. But I know that I can bring this whole thing across. Because if it's times on the one side, it's divide on the other. And what do we get? I get 14836.28, which corresponds to B. So if I start out with 14,836 Rand, and I invested in an option that is 11% interest per year, I'll get to 25 in 5 years' time. And so that's solving for the P value. Give me a thumbs up if you're all following okay. Nothing too scary so far. Fantastic. Okay. Well, let's do these two here. I don't think, did we do this in the last, let me just check. Did we do this one in the last lesson or not? Is this question, I think we did. It's feeling familiar. Just say yes or no in the chat if you recognize this question. Oh, you did do it, yeah. Okay, no, that's what I thought, yeah. Let's move on then. Okay, I want to do this one. I want to know, let's do this one first. Let's do some practice. You invest 1,700 Rand at an interest rate of 10% compounded quarterly. How much is your investment worth after 6 years? I'll give you a moment. And if there is a question, I encourage you to raise your hand and we can chat. But for now, we're just kind of getting the wheels moving, testing our basics. Is that a question? So we know that this is going to be that. What we don't know is what goes below the line, and we don't know what goes up here. So what do we think is going to be there? Well, this must be divided by 4 for quarters. Now this was 6 to start with, but we times it by 4 because there's 4 quarters in every year. And so, in fact, I've actually got the answer here. I can bring it up. If you want to see the full answer there, it should be 3,074.83. Okay, so these questions are not actually that bad here. I think you're all comfortable with that. So let's just do these two. These are all sort of past exam type questions. So you're given 25,000 invested in a savings account. Calculate the value of the investment of this after 5 years if the interest rates are that or that. We'll go with A and B. Yeah, where to? How can I help you? What's your question?
Hey, sir, how are you?
Very good. Very good.
Well, thanks for asking. Anyways,
Oh,
I wanted to ask real quick. So, our answer for the previous question, right?
yes.
Do we put the unit for the cents in terms of the as the decimals? Do we put a unit for it in terms of cents, or is it not
You don't have
necessary?
to. No, it's not. It's not. So, it just depends on the question. The question will tell you what to do, and I've seen it said in different ways. You normally
Mhm.
don't have to give cents. That's what I'm. You see that to the nearest rand. Normally, it's not impossible. They say cents, but 90% of the time, it's just the nearest rand.
Well,
Just listen to the instructions would be my advice. No,
okay. Thank you, sir.
cool. So we have monthly would be divided by 12, and then this would need to be 5 times 12. Now, what are we going to end up with? I get 43,222.89. Let's see if anyone agrees with me. Yep, Emmanuel agrees with me. Stefan Lala agrees with me. Let's see about B. Who can find me the answer for B? Yeah, so what I've got here is 42,703.61. Now, if I look at the two options, they both start with 25,000 Rand. Okay, so they both got the same amount of money in the bank. They both start with a nominal rate of 11% per annum. And they both start with the period of time being involved as 5 years. Which of the two, they sound like they're very similar. Which of the two options would you choose? Which of the two options would you choose if you were given a choice? Would you choose A or would you choose B? I can see in the chat, definitely people are choosing A, and that's because we know that A is the bigger amount. Now, what is causing A to be bigger if they have the same starting point, the same base interest rate, the same period of time? What is causing this one to be bigger? Anybody have an idea? Okay, you guys have nailed it. It's compounded more frequently. So in the one that's compounded monthly, the interest is added to the original principal 12 times in the year. And when you get the bigger amount into the principal or into the amount of the bank account, you get interest on a bigger amount, which gives you more interest. And so it starts to sneak ahead. whereas this is only done twice a year. And so the effective interest rate for A is higher than the effective interest rate for B. Now, just to make sure we're not going crazy with this, I'm going to ask you to do a C and a D for me. And it's along the same lines. So for D, or for C, I want you to compound this quarterly. So same information as above, except you're going to be 11%, but you compound it quarterly. And here you're going to compound it weekly. And I want to see what do you end up with for C and D. So what do you end up with for C or D? The 25,000 is going to be the same. The 5 years is going to be the same. The only difference is you're compounding quarterly or you're compounding weekly. Well, what do we get in the bank account at the end of 5 years if we compound it quarterly? So this was 5, but we have to times it by 4. And this was 5, and we have to times it by 52. Now, before we get the answers, I want you to think, which one do you think is going to have a bigger amount? Do you think the one that's compounded quarterly, or do you think the one that's compounded weekly is going to have a bigger amount? So if you haven't worked it out already, I want you to think about which one you think will be bigger. I'm going to do the amounts in a calculation so I can to the power of 20, and I get 43010.71, and on this side I get 1 plus square root divided by 52 to the power of quite a lot. 260 is what I would imagine it's going to be. And what do we get for that one? Well, we get 43306.16. Now, those who said that you thought that the weekly compounding would give you the biggest amount, you can give yourselves a hand clap. If we look at the different amounts that we ended up with, I think that they tell a story. If we had to imagine which option we would all choose, we would all choose D as our first prize because it's the biggest. Then what would we choose after D? What would be the next best prize after D? Okay, it would be what? It would be A. And what would it be after that? Which one would we choose next? Then we would choose C, and then we would choose B. Yes. So what I want to say to you is, if we talk about, we're going to have to talk about something called the effective interest rate. And what the effective interest rate does is it takes into effect the effects from shortening the compounding period. So the shortest compounding period was weekly, and that's why it was the favorite. The next one that was the next most sort of coveted was the monthly one, because that's the next shortest. And so we say that D has the highest effective interest rate, and then A would have the second highest effective interest rate. Now, how can we see this instead of having to do the whole calculation like this, which is useful to do, but sometimes we want to do it in a quicker and a more effective way. There is a wonderful formula for the effective interest rate, and it is, it's going to be the following. Let me write this down. 1 plus I nom over m to the power of m minus 1. And what this calculation does is the I nom is the original interest rate that you're given. The m is how many compounding periods there are in 1 year. So I will do A with you to show you how this works. So the effective interest rate for compounding monthly from A would be 0.11 divided by 12 to the power of 12 minus 1. And I want you to put that in your calculators and tell me, what do you get? Out of curiosity, what do you get for that? Now, if you times it by 100, you can get it in a percentage form, but initially it comes out as 0.0 or 0 point something like that. So what are we getting? If you can give me the percentage one if it's easier. So Tati has got something. Who else feels like they have? Who can confirm Tati's work? I suppose I could do it. Oh, so Melo is there. Okay. So we've got 11.5% per annum as the effective rate for compounding monthly. And Emmanuel agrees. So that is awesome. Okay, let's do B. Stefania and Lorato agree as well. So we know we're on the right track. Now, if I want to do this for B, I do the same thing, except in B, I wasn't compounding monthly, I was compounding semi-annually. So I divide by 2, and then I raise this to the power of 2, and I take away 1. So what do I get for the effective rate for B? What do I get for the effective rate for B? So it looks to me like people are getting 11.30% per annum. That's how much interest you get per year if your compounding interval is only twice a year. Now this, I feel like I'm on the right track because I can see that A was better than B. So what I want you to do is I want you to calculate for me the effective rate for C, and I want you to do this all by yourself. I'm taking away some of my help. Can you work out what the effective rate is for C when you compound quarterly? So the nominal rate hasn't changed, but what is changing is that. And what are we going to get for this one? So Lorato has told me, so as Tebogo, we get 11.46% per annum. And again, that makes me happy because I can see this is better than B, but not as good as A, which, you know, in the world we're living in, that makes a lot of sense. So let's just do this last one, and then it's time for a break. I'm pushing you hard today. I want to know, what is the effective interest rate for D? what do we think we're going to get? Okay, we've got Futi. Okay, we agree. So actually, guys, I think we've nailed this. So this is 11.6.1% per annum. And what I see as I look back over the evidence that you've created is if I was choosing an option, if I wanted the highest effective interest rate, I would choose D first. So I'll put that at the top. So I would choose D first because it gets 11.6% per annum interest. Then I would choose A because it gets 11.57, not far behind. Then I would choose C because it's 11.46. And lastly, I would choose B. And what I love about this formula is it tells the same story as this. And so often when we ask students to find the effective rate, what it's doing is it's summarizing the effect of the compounding interest over different intervals. But often I find students find this idea confusing because they don't know this formula. And so I don't think you will have it perfectly, but can I have a thumbs up if you feel like you understand the idea behind the effective interest rate? And if there were some uncertainties, maybe now is a good time for questions before we go off into our break time. Okay, awesome, everyone. I'm not seeing any questions right now. And so I think I have really been pushing you. It's really important everyone stands up, gets away from their desk, and joins me. Oh, Lorato, you have a question. Can we unmute Lorato? And then we'll go take our break now. Hi, Lorato. What's your question?
So at school, I was taught I don't know how to put it, but the 0.11 and over 2, the way we were taught would be 11 over 200.
That's fine.
Okay, so
it's equivalent. So 11 over 200 is just basically doing like that, which is kind of like saying it's equivalent. It's exactly the same thing. But you know what? I think lots of people were thinking that. So thank you for asking the question. What Lorato was asked is 11 over 200 is exactly the same as 0.11 divided by whatever thing is relevant. Okay. Great question. Okay, everyone on your feet, let's turn on the cameras and let's all just stand up for a second. Stretch out our arms. Stand up nice and straight. Put your chest out. Oh, feel that nice stretchy feeling. And, oh, goodness gracious. Let's turn around a little bit. Okay. And once you've turned around a little, let's shake out your arms. Shake out your arms, shake out your legs. Get nice and loose. You want to get all that tension out of your body. Let's do a nice stretch. Oh, that feels good. And let's do another stretch. Okay. What haven't we done? Let's roll the shoulders. Let's roll them forward. And then let's do one more shake of the arms just to get the blood moving. Shake of the legs. And let's get the heart rate up. Let's do some air skipping. Actually, you know what? We haven't done jumping jacks for a while. Let's take it up a notch. Let's do 20 jumping jacks. We'll start in 3, 2, 1, and let's go. 1, 2, 3, 4, 6, 7, 8, 9. Halfway. These are much more tiring. 11, 12, 13, 14, 15, 16, 18, 19, 20. And I am now quite tired. Ooh, let me know in the chat if you find them harder than air skips, because I definitely do. Maybe it's old age, but yeesh. And here is your brain break for today. Can you solve can you solve these Maths 24 puzzles? Who thinks they can do it? Yeah, Andile has got 4 times 3 is 12. Andile, you're close, but you need to make a modification with the brackets. What do you need to do there? Oh, that's interesting. 3 plus 3 is 6 times 4 times 1. Or you could do that. That will give you 24 as well. Who else can get to 24? There's still the blue and the yellow. The glory can be yours. Let's have a look. 7 times by 4 gives you 28. Minus 6 plus 2. The glory is, wait, not 28, it's 24. So this, 24. Done. And Sonic has said 7 times 4, very similar, 7 times 4 minus 6 minus 2, which also gives you 24. So the blue has fallen. Can we do the yellow? Can we do the yellow? I'm feeling like, what can I do here? 4 times 2 is 8. Oh, I think Lebo has beaten me to it. 5 plus 5 is, oh, well done, Lebo. That was good. That was a sneaky one. 5 plus 5 is 10. 10 times 2 is 20, and then 24. Okay, hope everyone enjoyed the break. Let's head back to interest. So as we get to more complicated interest questions, what we start to do is we start to vary more things. So let's have a look at this question here. So it says, Tabo invested 1,000 Rand in the bank for 10 years. The interest rate was 6.5% compounded quarterly for the first 3 years. Then for the next 5 years, the interest rate was calculated at 7.2% compounded monthly. And then for the remainder, however long that was, the investment, the interest was 7.8% compounded semi-annually. So what we notice is we have 3 different interest rates. And what I suggest students start getting used to is something called a timeline. So if I think of this timeline, the very first part of the timeline is T0 or T0, and the very end of the timeline would be T10, which is 10 years. Give me a thumbs up if that makes sense to you from the question. Now, brilliant. Now, on this timeline, there are some important points on the timeline. The first one will be at T3 because of the first 3 years. Then it says it won't be T5. The next important period is T4. 8, because it says for the next 5 years, the interest rate's like that. And then for the remainder, which is here. So if you kind of follow my coding of the environment, this bit over here has a certain interest rate. This bit over here has an interest rate. And then this bit over here has another interest rate. Now, we start this journey with 1,000. So what I do is I say plus 1,000. Now, all I want to do is grow to that point. Can you guys help me get to that point? And then I'll worry about getting to the end of the line. Because we want to try and figure out how much Tabo has in the bank account at the end here. So can you help me work out what that first bit will be? So it's definitely going to have 1,000. Okay, so I see lots of students are saying that you end up as 13.41, which is correct. But what I'm going to suggest is instead of putting it into its decimal format, we just leave it. So we go 0.065 divided by 4 because it was quarterly and it's for 3 years. So this must be 3 times 4. Now, that amount is in fact 1213, but at the moment we are sitting here on the journey. And the big idea I want to suggest is that for this next part of the journey, this piece over here is the amount I want to work with. And so if I want to work with this and I want to now go all the way to here, I want to suggest we can keep this here and we simply just add an extra bracket. And this blue block is almost the p-value that feeds into this. And what I'm going to do now is I'm going to say, what is the interest rate that it needs to grow for here? Well, it's normally 7.2%, but it's compounded monthly. So this is going to be 12. But what I want to ask you is, what is the amount? What is the number of time periods that I put here? What is the number of time periods that I put here? So because this, if I look at my timeline, I go from T3 to T8, that's 5 years, but I don't want years, I want months. It's 5 times 12, which is 60. Now, if I put this whole long thing in my calculator, I want to see what you guys get. What do you get if you go 1,000 times this to the power of 12 times open bracket this? What do you get in your calculator when you get to that point? Takes a bit of time to put that into a calculator. What do we end up with? So people are ending with 2024.64. And that's correct. That's the amount of money that is sitting in here. But the question didn't say after 8 years, it said after 10 years. And so what we're going to do now is I'm going to attempt to grow this whole thing here for another 2 years. And so you can imagine this whole front thing is a block, and we get 1 plus, now I have to go and look at my interest rate, 0.078 divided by semi-annually is 2. What's the thing up here going to be? Okay, because it's 2 years, I can see it's 2 years, and there's 2 6-month periods in each. This should be 4 or 2 times 2. And now I want you to use your calculator to work out magically how much money is sitting in the account after all 10 years, even though you've had the interest rate vary on you 3 times. Can you work out? And then I will reveal the answer in a moment from this block below. What do you get for your... Pop your answer in the chat there. What are we getting? So this, sometimes when I show students this long line, they get a bit intimidated. But when you understand all that happens, I think for students, you really want to get used to a timeline and drawing the timeline and then getting used to the way in which the first bit feeds into the next bit, feeds into the next bit. So be careful here with your calculator. So you should be getting more than 2024 because it grows over these periods of time here. So you get, let's have a look here. So after 10 years, it says here, we got 2024. Oh, then we couldn't have got 2024. 2024 is what we got at the end, everyone. It wasn't 2024 halfway through. And I think I made that, but I might have kind of, without checking that, said it was. You should get, if you look at this, here's my timeline like I had, and you should end up with 2024.64 as your final answer. No worries, Sonic, I understand. I think everybody understands. So, okay, this, yeah. Let's just check. No problem, Sonic. So T2 is, then Andile picked that up. It's 1737.34. Okay. Let's just take a moment and see that everybody understands that what I got in the end here, and you do get 2024.64. So you should have a 12 here. So that should be a 12. Sorry, this should be, yeah, 12. This should be a 60, and that should be a 4. Okay, so if you made a mistake, why don't you have another go? You should be getting, even if you do it bit by bit, you should be getting over here. So where could you have gone wrong? So try it again and give me a thumbs up once you've got it correct. So in your calculator, what I would do is I'd have 1,000, then I'd say times, and then I would go 1 plus, actually, let me do this together with you. 1,000 times, open bracket, and then 1 plus that, 0.065 over 4 to the power of, and then I get 12. And you know what? I'd press equals. Press equals, and then the thing is in your memory, and then you go times, and then you open another bracket, 1 plus 0.072 over 12, close bracket, to the power of 60. And I'm going equals again, because I've got this in my, I don't have to keep everything on the screen. And then I go times, open bracket, 1 plus 0.078 over 2, close bracket, to the power of 4. And I get 2024.639, which gives me that. So I think the people who made mistakes, what you need to do is after you do each piece, just press equals in your calculator so that your brain can kind of get a break. Okay, that's my tip. Did that help? Did that tip help for those who were struggling with that? Okay, while you're working through that, what I'm going to do is I'm going to put another question on the board for you to work through. Clomelo, that's why I like live classes. We can problem solve together, you know, and we can find out as we go. So I'm going to help those students who are still finding it unsure, but for the rest of you, I want you to try and solve this multiple choice problem for me. And then I'm going to talk about that step that we were doing there. I'll leave it on the board. I'd love some questions if you feel like asking questions. Otherwise, get cracking on the next one. Which one do you think is going to be correct? So for those who are doing this question, I want to suggest to you, why don't you set up a timeline to help you keep track of what's going on in this question? See if you can mimic the structure that's on the board and then adapt it for this question. Which option do you think? I'm a big fan of timelines, as you will see in later lessons. I think they're the best thing ever because they help take my brain and give it a break when all the information is in the text. So I'm going to say T0, T10, and I'm going to say T2 is quite important. And what I sometimes do is I say, okay, well, I start with 11,900. And sometimes it's even helpful to know what the interest rate is here. So the interest rate initially was 0.075, and it's annually, so it's divided by 1, I guess. And then for the next period, it changes. And what does it change to? It changes to that, but it's per. Okay. You know what? Again, it says, you're going to have to assume it's per annum here because it doesn't say it's compounded any differently. So it's going to have to be per annum, which makes life very simple because you start with 11,900 and it grows for 2 years and the interest rate is just going to be 0.075 to the power of 2. And then instead of having to go back and start again, all you do is you pretend this is the new p-value. So if you imagine like this is the input, the p-value, and what comes after that? Well, it's just 1 plus, and here it's 0.085. And what is this power going to be? What's that power going to be? Given what my timeline is saying. Yep, because it's per year, and these are all years, it's going to be 8. And so now I just need to put this rather long thing in my calculator, and I'm going to do it 11,900 times, open bracket, 1 plus fraction button, 0.075. And you don't even have to put it over 1. Well, you can if you've got a fraction. To the power of 2, I go equals, so my life is a bit easier, times, open bracket, 1 plus 0.085, close bracket, to the power of 8, and I get 26412.03. Is there anything that looks 0308? Well, it's not going to be that, it's not going to be that, it's not going to be that. There's obviously a bit of a rounding error, but it's going to have to be C. So C would be the correct answer. Give me a thumbs up if you followed that. Give me a thumbs down if you are feeling unsure about that example. Okay, everyone. Well, then I think we've done really well today. We've really gone much deeper into compounding intervals. We've also looked at something called the effective interest rates and how effective interest rates summarize what compound interest is doing. And then at the end here, we've started to vary. We've used things called timelines to vary the time periods and the interest rates when saving amounts of money, which I think is more than enough for one day.